Okay, welcome members. Today we are going to see more questions. Now we are going to see a new subtopic about inequalities. It's called linear programming. Some people call it LP. Okay, in LPs, the values we deal with are always in the first quadrant, of course in the first quadrant, the first part. They are always positive values. The following statements can be written as inequalities. So if we have these ones, this is the inequality, these ones, this is the inequality, this one, they are many, like below, above, but I'm not going to exhaust all. So let's go through this question. So I'm going to handle this question, and the working is already there so that we can save some time. In a furniture company has shillings 150,000 to invest in making chair tables X. The tables are X and chairs are Y. So it means that when you get the cost of each table and the cost of each chair, of course you cannot use money more than this. So the money you are going to use for making this and for making the table should not exceed. It means that it's going to be less or equal to. That's why if tables are X and chairs are Y, when you get 50,000 for making each table plus the 30,000 for making each chair, they should not exceed this amount. Why? Because it's the amount the company has. Then if you divide through by these 3, 4 zeros, I think you get this. You simplify it. This one is equation 3. I'm going to come back to this. Then we continue. The company has storage space for at most 5 items altogether. Meaning a day or if at any time, if you make those items, they should not exceed 5. Say at most, the sign is here. At most. Okay. Then, of course, you cannot make 0 chairs because we say you only deal with positive. You cannot be having less than 0 chairs or less than 0 chairs. I mean 0 tables. So we say, or you can't, in simple terms, you can't be having negatives here. That's why this one is greater or equal to 0, this one is greater or equal to 0. So now, from there, after extracting this information out there, we come now from inequalities to boundary lines. I think from the previous lessons, you can now know what we deal with here. We just change the inequality sign with an equal sign, replace with an equal sign, the same here, and equal sign, the same here. Then, we need to, now these are lines, we need to plot them, but we need only 2 points on them. We use the intercept method. When x is 0, so that y will be 5. Then when y is 0, x will be 5. So, now you come and plot, you have 0, 5, 0, 5, which is there, then 5, 0, which is there. So it's that now I plot this, and this will be the line. X plus y equal to 5. This is just plotting the line. Then when x is 0, so when I put here 0, is that y is divided by 3 will be 5. Then when y is 0, is that x will be 3. If you divide 5 and 15, you get 3. Here's a point 0, 5. And then 3 0 is here. And then we join this line, and that's the we say. Now we say that we can skip the testing part because these 3 inequalities, or is the wanted region is below them. Meaning the unwanted is going to be above them. So these lines, this is the above, this is the above. Below them, I think you can see. Now, the question is telling us that shade the unwanted region. Meaning the unwanted region is just the region which is going to be above them. We know first time we base on the signs. We said when you have less and less, it means that the wanted is always below if you have this one is less or equal to even if you have less. The wanted is always below, the unwanted is always above. So that we want to change the unwanted so and change it above them like this. Then for these two, when x is equal to 0, we say when x is equal to 0, this is the line. Y-axis is the same as x equals 0, and then x-axis is the same as y equals 0. For them, they are plotted, but we want also x equal to 0. So this is the wanted, and this is the wanted. For this one, this is the wanted. So meaning this is unwanted. Because because we want values of y greater than or equal to 0. Then for this one, we want values of x greater or equal to 0. So this is the 1 and this is the -1. So that's why I was just shading off that side. And now remember, as you see, this is what we call the feasible region. After getting now the feasible region, after getting the feasible region, we want to get the points in the feasible region according to that question. So then what this says, find the list combinations of tables and chairs a company can make. Now these are the combinations. We say we take all the points on the boundary. So we have 0, we have this point to this. Then we can also have 1, 1, 1, 2, then 1, 3. Then we can also be having 2, 1, then you see those are the only points. So if I'm to answer now part B, the points are going to be 0, 1, comma, 0, 2, 0, 3, 0, 4, and 0, 5. Then we come to 1, 1, 1, 1. Then we have 1, 2. Then we have 1, 3. This one is on the line, but we said you can take it because the line is solid. Because this line is solid, you can take it 1, 3. Then you also have, that's all we have also 2, 2, 1, 2, 1, 2, then 1. You see 2, 1. Then you can also take this as 3, 0. 3, 0. We also take this, we also take this, and we also take that. So we have this as 0, 0. We also have this as 1, 0. We have this as 2, 0. So those are the points in the feasible region. So how many tables and chairs a company should make to maximize profits? Now, we don't ask that. The profits are going to be part C. They don't ask that. If we have X and Y as the tables, they don't ask that. Each table yields a profit of this. So meaning, I get 80,000 times what each table yields plus what each chair yields. Each chair yields this profit. So 45,000 times now Y. Now, I need to know which one is going to maximize my profits. And you say, always figures that are going to maximize, points that are going to maximize profits are always at corner points. So for maximum values, you check at the corners above. So in most cases, you are going to get the values from here up. So you see, the values we have are going to take from here going up. So I can take 1, 3. I can take a 4, 0, I can take 5, 0. It's up to you. So now, if I take, if I take 4, 0, I mean 0, 4. If I take 0, 4, so you get this. You shall be happy. Now X is 0, then Y is 4. When I multiply 4 and that, I think I will be getting 180,000. Now, I can also test for this 5. 0, 0, 5. See that? X is 0, Y is 5. 5 times 5 when you add a 5, when you add, I mean 45,000 times now Y is 5. I think the value we get there is 225,000. Now let us test also. Of course, this one can't give you a value bigger than that. Let me also try 1, 3. If I try 1, 3, let me try 1, 3. When you try 1, 3, we have 80,000 plus 3 times this plus 80. I think you can't get a bigger value than that. So here I think we get 135,000. Let's 16,135,000. Then plus 1 times this, we get 80. The value we get here is 215,000, and you see that the big value that we have is this one will give us. Now, when you try these ones, I'm sure you are not going to get a value bigger than any of this. So now, so that to maximize profits, this is what we are going to have. And now, this man should make 0, x was tables, 0, tables, and 5 chairs, and 5 chairs. So let's find the profit. The profit will be 225,000 shillings. So that is how we handle that number. Now, so members, wait for more about inequalities. About linear programming. I'm going to do some more examples. Don't forget to subscribe to the channel. I wish you the best.